We have the labor demand equation because the slope is negative. So this is labor demand here. Labor supply because its slope is positive. So this is labor supply. This models worker behavior, and this models firm behavior. The labor supply curve slopes up because generally people will work more when the wage goes up. This models worker behavior because workers supply their labor and will supply more of it as the wage rises. This model firm behavior because as the wage rises, firms will hire fewer and fewer employees. In other words, as wage rises, firms will demand fewer and fewer workers. I've copied and pasted these equations into an Excel spreadsheet. And we'll compute the equilibrium employment level, the equilibrium wage, worker surplus, firm surplus, and total surplus in that spreadsheet. So that is my labor demand curve. This is my labor supply curve. To find the equilibrium employment level, I set demand equal to supply. Here I have the demand curve equal to the supply curve. Then I subtract 3.7 from both sides of the equation and add 0.019 e to both sides of the equation down here. I factor out e on the right-hand side of this equation down here, and then I divide both sides of this equation by this coefficient of e. So I calculate this value here, down here in cell B14. And I get an employment level of 744.068. I'm going to copy and paste that into Cengage now. I only need 2 decimal places, so since that third decimal place is a 7, the second one is a 7 when I round to 2 decimal places. This is the diagram I copied in from Cengage now. And you can see when employment is 744.068, demand and supply of labor intersect. And the wage rate is somewhere between 32 and 34. To get the wage rate, I substitute the employment level into the demand curve. And when I do that, I get a wage rate of 33.4627. To 2 decimal places, 33.46. I can double check that I did my work correctly by plugging the employment level in at the equilibrium into the supply curve. And I get the same value to 2 decimal places. Worker surplus is found by calculating the area of the triangle that is from this part of the labor supply curve up to the equilibrium wage and then back over the equilibrium. Why is that? Well, the first worker hired would be willing to work for this wage, but is getting paid this amount. So that worker has a lot of surplus. The 600 worker hired has a reservation wage equal to that value, but is being paid that wage. So you can see worker surplus is declining as the firm hires more and more workers. To calculate the area of this triangle, the base of the triangle is from the equilibrium wage to the intercept of supply. So B17 is the equilibrium wage, that height. 3.7 is this value, the intercept of supply. And then we multiply that by the height of the triangle, which is the equilibrium quantity. We divide that product by 2. And we get a worker surplus of $11,072.74. Since the labor demand curve represents firm behavior, this triangle up here, up to the demand curve, is producer surplus. Why is that? Well, when the firm hires the first worker, it is willing to pay up to that amount to that first worker, but only has to pay that value. For the 400th worker hired, their firm would be willing to pay that 400th worker that wage, but only has to pay that value. So you can see the producer surplus is declining as more and more workers are hired by the firm. To calculate that area, we take the intercept of demand, which is 47.6, subtract off the equilibrium wage, which is 33.46. We take that difference and we multiply that by the height of the triangle, the equilibrium quantity of employment, and then divide by 2, and we get a producer surplus of $5,259.55. Total surplus is just the sum of these two. So total surplus is this huge triangle, which equals $16,332.29. If ABC Incorporated is the only employer in the region, the firm is a monopsonist. In this scenario, it can be shown that the marginal cost of labor curve that the monopsonist is faced with has the same intercept as the labor supply curve and is twice as steep as the labor supply curve. Thus, the marginal cost of labor curve is, so the marginal cost of labor curve has the same intercept but is twice as steep. So we got to make that 0.04, 0.08. So this is the labor supply curve, and this is the twice as steep marginal cost of labor curve. The firm maximizes profits when it sets the marginal cost of labor equal to its demand curve. So this point right here determines the quantity of labor hired by the monopsonist. This diagram here with this intersection is the competitive equilibrium. Again, the monopsonist will set marginal cost equal to the labor demand equation to determine the monopsonist level of employment. Here I have the marginal cost of labor curve, which again is the equation that has the same intercept as labor supply, but is twice as steep. To determine the employment level of a monopsonist, you set the labor demand curve equal to the marginal cost curve it's faced with. We subtract 3.7 from both sides of this equation. We add 0.019e to both sides of the equation and get this value. And then we use the distributive property and factor out the employment level. And then we divide both sides of this equation by the sum of 0.019 and 0.08. So the employment level is equal to 443.43 to 2 decimal places. If the firm has a pretty good idea of what the labor supply curve is, the minimum wage, the last person hired by the monopsonist, is the value of the employment level, 443.43, substituted into the labor supply curve. So the intersection of these two lines determines the employment level. When I plug this employment level into the labor demand equation, I get the lowest wage the last worker hired will work at. We plug the monopsonist level of employment into the labor supply equation down here, and we get a wage of 21.44, this value here. So because the monopsonist is the only demander of labor in the region, it only has to pay a wage equal to $21.44 per hour. Worker surplus is the area of the triangle that is a result of this wage being paid to employees down to the labor supply curve. To calculate the area of this triangle, the height of this triangle is the difference between the wage we just calculated, 21.44, minus the intercept of the labor supply curve. times the employment level for the monopsonist divided by 2. So worker surplus is $3,932.68. Firm surplus is the area of the trapezoid that goes from the wage up to the labor demand equation. So it's this trapezoid right here. And the area of the trapezoid is the average of this height and this height times the employment level. So we have to calculate this value. To calculate this value here, we plug the employment level of the monopsonist into the labor demand equation. When we plug the employment level, B14, in the labor demand equation, we get 39.17. So this height here is 39.17. Firm surplus is the average. This right here is the average of this height and this height. So 47.6 minus B17 is the difference between this value and that value. B16 minus B17 is the difference between this value and that value. We average them and then multiply that average height by the width of the trapezoid, which is the employment level for monopsonist. And we get a firm surplus of 9,733.38. Total surplus is the sum of worker surplus and firm surplus, 13,666.06. Thus, the monopsonist reduced employment by, to calculate the employment change, we take what it was in the competitive market and subtract off the employment level in the monopsonist market, which is 300.63. This pushed the wage down from this value down to that value. So we have to calculate the difference in the wage. The difference in the wage is 33.46 minus the wage the monopsonist has to pay. 12.03 is the difference in those two wages. So wages fall by 12.03 if a competitive market is monopsonized. The reduction in total surplus is the deadweight loss. Deadweight loss is the area of this triangle here. The height of the triangle is the difference between these two wages. The width of the triangle is the difference between the employment level in a competitive market and the employment level in a monopsonist market. So this right here is the difference in the two wages here and here. This is the difference in the employment levels, competitive and monopsonist. And we divide that by 2 to get the area of the triangle. So the deadweight loss is 2,666.224. Or to 2 decimals, 2,666.22. If you were to add the deadweight loss to the total surplus, you get the total surplus in a competitive market. I'm going to check my work and I should get everything correct. And it looks like I do get everything correct.